Begin with what we want to know about reciprocal functions. Reciprocal functions are exactly what we would expect them to be like. This whole idea of taking a number and flipping it over, and that's what we're going to do. So let's begin by talking about what we already know. As far as the words are concerned, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And now let's introduce a new reciprocal function for each one of these. If you take a look at sine and you want its reciprocal function, you'll be coming up with a new function called the cosecant function. It's pronounced cosecant, but we abbreviate it CSC. And I'll have handy ways for you remembering all the details of what goes with what. But anyway, the reciprocal of sine is cosecant of x. So if we started out with sine being opposite over hypotenuse, that must mean that cosecant is going to be hypotenuse over the opposite side. Again, cosecant. Let's move on to starting with the cosine being adjacent over hypotenuse. And now we have our next reciprocal function, and that's called secant. It's pronounced secant. It's spelled out like this, but again, we use the abbreviations SEC for secant. While I'm thinking about it, I'm going to show you that the SIN is actually an abbreviation for a longer word, sine. COS, cosine, is COSINE, and of course tangent you probably know, TANGENT. So just like we have full words for these three-letter abbreviations, we've got full words for these as well. Excuse me. Going down to the last one here, if I start off with tangent and I want the reciprocal function for tangent, then that function is going to be called the cotangent. And if tangent is opposite over adjacent, then cotangent is adjacent over opposite. Now, I told you to have a handy way for you to remember all these matchups here, and I do. And probably one of the handiest ones, if you have to use reciprocal functions, you have with you as long as you have your calculator. If you hit the trig button on your calculator, you'll see a box that comes up like this. And these three here will be grayed out for you, meaning you can't use them for calculations, but you will be able to read them. And so if you look at what I've written here, sine, cosine, tangent, cosecant, secant, and cotangent, you'll see that your top trig buttons follow the exact same pattern. It's sine, cosine, tangent, and then you can start at the top of the next column, cosecant, secant, and cotangent, and that will help you keep those matched up if it's hard to remember. Tangent and cotangent are easy to remember, but sometimes it gets a little bit tricky with the cosecant and the secant. They sound so much alike. Okay, so that's great if you have the inspire. You can just hit that trig button and match them up. What happens if you don't have the inspire? Well, that's where something we call the magic hexagon comes in. I'm going to make that a little bit bigger for you. This is something you should get in the habit of being able to draw from memory, because this has reciprocal function relationships in it, but it also has a lot of other relationships in it that we'll be using later in our trig units. So let's look at the fact that we have sine, cosine, tangent, and then as you keep writing, you're going to be putting the word co across from the original. So you put a 1 in the middle, and we'll have a cotangent here. That'll be easy. So starting out with those first 4 circles should be no problem. Sine, cosine, tangent, cotangent, and then we'll move on down to the bottom, secant and cosecant. And if you remember when you're setting this up, that the S's are here and the C's are here, that might help you. Everything on this side of the magic hexagon starts with a C. There's also a 1 in the middle. And the 1 in the middle is what's telling us to perform the reciprocal operation. If I start out with sine and I want its reciprocal, I go through the middle and I get cosecant. If I start out with a secant function, I want to know what its reciprocal is, I go through the middle and I get cosine. If I start out with the cotangent function, I want to know what its reciprocal is, I get tangent. So committing this to memory will be very handy for you. Either this or using your inspire if you always have one with you, that'll help. But again, there are lots of other relationships in here that we haven't talked about yet that we'll be using this for. So let's move on to a couple of things in understanding. When we talk about understanding, you can see that we're talking about the reciprocal function value. Sine of theta is equal to this function value, 3/4. Then that must mean the cosecant of that same angle theta is equal to 4/3. All we did was flip the fraction over, take its reciprocal. If we find the cosine of theta and it turns out it has a radical on the bottom, we should leave that radical on the bottom if we're going to need to come up with a reciprocal function. Because when you come up with the reciprocal function, you can just flip that fraction over. You do not have to rationalize it here whenever your final answer is supposed to be for the reciprocal function. It's just a little bit easier. There's nothing to stop you from rationalizing here, but then you've got to flip it over and rationalize again. So we don't want to do more work than we have to. This last one shows a cotangent that's not a fraction. But you can write negative 0.72 as a fraction. Negative 0.72 over 1, well, that's kind of complicated, but you could use your calculator to clean up. It's also negative 72 over 100. So when we find the reciprocal function tangent, we can take that negative 72 over 100, flip it over. We just want to be sure to reduce that answer before we circle it. There's one other thing going on here. Maybe it's not obvious, but when you take the reciprocal of a positive number, you get a positive answer. When you take the reciprocal of a negative number, you get a negative answer. So if you have a negative sine function, you should have a negative cosecant function. If you have a positive cosine function, then you should have a positive secant function. Function values is what I'm speaking of here. There's one other way you could do this. You could do this visually, and that's kind of handy when you are drawing out triangles, as you will quite a bit in tonight's homework, or tomorrow's homework. Homework number 3 in any case. Okay, so let's say we start off with this point P on the unit circle, and we've got a -3, we've got a 4, and we've got a not the unit circle, we've got a hypotenuse of 5, a circle with a radius of 5. And now we want to figure out some reciprocal function. Say we want the cosecant of whatever that angle theta is. Well, if I know that cosecant matches up to sine, and I'll get that from my magic hexagon here, I know cosecant is reciprocal of sine. Sine is opposite over hypotenuse, so cosecant would be hypotenuse over opposite. You can just look at your triangle here and say the hypotenuse is 5 and the opposite is 4, so there's your cosecant function. However, when you do that, be careful. Be sure that you're taking the signs along with this. This is a +4 because we went up, so this is supposed to be a positive number. If you were being asked about the secant instead and you have a -3, then you want to be careful to take that -3. That's why it's helpful to label your pluses and minuses, even though you know that right triangles have lengths that are positive numbers, but putting the signs in there will keep you from running into trouble when you have to do these calculations. So let's do 3 examples from the homework page for tomorrow. We have terminal side of angle ROP in a standard position intersecting a unit circle. Okay, if it's a unit circle, we know that the hypotenuse will be equal to 1. Here's the point. It's a negative and a negative, so it looks like we're down in quadrant 3 for this one. So I'll draw out my triangle in quadrant 3. I know the hypotenuse is equal to 1. My x-coordinate is negative square root of 5 over 3. My y-coordinate is negative 2 over 3. And now let's answer the questions here. I want to find the sine of angle theta. I know, and don't forget, this is theta in here. And instead of using a wedge, I'm just going to be marking that as theta. But you'll see that theta is always touching the x-axis. Okay, so the sine of theta is opposite, negative 2/3, over the hypotenuse, which is just 1, so I've got a negative 2/3, and I'll circle that. Move on to get cosine of theta. Cosine of theta is adjacent, which is a negative square root of 5 over 3, divided by 1, but I don't even have to write that. I'm just going to circle the negative square root of 5 over 3. And then we're going to find tangent of theta. And we've got tangent of theta is opposite over adjacent. Well, whenever you put or opposite over adjacent, but also it's sine over cosine. So when I do tangent, I'm actually looking here. I have these already. I have a negative 2 over 3 and a negative square root of 5 over 3. Well, I know that when I put one fraction over the other and the denominators are the same, they cancel out. So I can write it as -2 over minus square root of 5. Hopefully you would turn that into a positive result pairs make positives when it comes to minus signs, and you would rationalize by bringing the square root of 5 up to the top of the fraction and writing a plain old 5 down the bottom of the fraction. It's a bad looking 5. We'll fix that up. So those are your three basic trig functions, but you've done that before. Now we're being asked to move on to the three reciprocal functions. And when you see my key, you'll see that I didn't do them in this exact order. This was out of the textbook. You know, you could be asked in any order, but I'm going to match up just so that you can get used to that idea of matching up. Sine, and oh, you know what? I'm going to bring my magic hexagon over. We'll use that. And you want to do that too as you're working. As a matter of fact, when you get a quiz, when you get a test, the first thing you should do for yourself is recreate that magic hexagon. If you've memorized it, then you can use it, and you'll be using it for lots of other things besides these reciprocal functions. So sine and cosecant are reciprocals, so I'm going to write the cosecant of theta. Well, if I already have an answer for the sine, I can just take that answer and I can turn it over. Keep the same sign. Remember, if the sign is negative, cosecant will be negative. When you take a reciprocal, you keep the same sign. On the next one, cosine, reciprocal of cosine is secant. So the secant of theta is just the reciprocal of this here. That's 3 over square root of 5, but it's negative, so we'll rationalize as we go. It's negative 3 square root of 5 over 5. And then this last one down here, and here's where that understanding page comes in handy. Tangent and cotangent are reciprocals. Well, if I started the tangent like this and I don't rationalize it, I had to rationalize it if I was asked for that answer, but if I know I need a reciprocal of this one, rather than flipping this over, let me flip this over. It makes it a little bit easy because there's no rationalizing to do then. In this section, well, we have a circle, but it's not a unit circle, it's a radius r. So the only difference from the last set of problems to this set of problems is now we're going to have to calculate what that radius is. As a matter of fact, it'll ask you to find r first. So we've got a point -4, 8. We're going to go -4 to the left and 8 up, and for, whoops, don't like that. Let me redo that. For the time being, I'm going to mark that hypotenuse as r because we're going to have to solve for that. And yes, we'll solve for it using the Pythagorean theorem. Here's theta, here's my right angle. So we'll say r squared is equal to 8 squared plus a -4 squared. It's going to be 64 plus 16 is going to give me an 80 for r squared, which means r is equal to square root of 80. And that's a number we would simplify if we had to provide an answer for that. And that would be 20 times 4, 16 times 5. So 4 square root of 5. And now I can label that piece of my triangle. And then I move on to find my cosecant, secant, and cotangent. Here's where it might be helpful to do it visually. Cosecant of theta, and if you had your magic hexagon there, which I should go grab, right here. But you should have yours on your notes page. Oh, there we go. Okay, so cosecant of theta is the reciprocal of the sine function. If sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. If you look at your triangle, the hypotenuse is 4 square root of 5. The opposite side is 8. You certainly want to reduce that if you can. You'd end up with square root of 5 over 2. The next one, you're asked for secant of theta. So we'll go to our magic hexagon here. That's the reciprocal of cosine. Cosine was adjacent over hypotenuse, so this one has to be hypotenuse over adjacent. 4 square root of 5 over -4. My answer is a negative square root of 5. We'll clean that up. And then the last one there, cotangent of theta, reciprocal of tangent. Instead of being opposite over adjacent, it's adjacent over opposite, so it's a -4 over 8, which is a -1/2. And then the last set of problems that you have refer to quadrantal angles. Anytime you see trig function values of 1, 0, minus 1, or undefined, 1, 0, minus 1, and undefined, you should be immediately thinking about your quadrantal angles: 0 degrees, 90 degrees, 180 degrees, and 270 degrees. And when you think about that, you should be thinking about those points on the unit circle: 1, 0, 0, 1, minus 1, 0, and 0, minus 1, and the fact that those points on the unit circle are giving you sine and cosine values all the way around. Well, they're also giving you tangent, cotangent, cosecant, and secant values. It says if cosine theta equals 0, remember cosine is the x-coordinate, so at 90 degrees the cosine is 0, and at 270 degrees the cosine is 0. It says find all possible values of sine, cotangent, and cosecant. You're being asked to find the sine of 90 degrees, the cotangent of 90 degrees, and the cosecant of 90 degrees. And then, because this point also had a cosine of 0, you'll have to repeat all three down here. I'm just going to do the one for 90 degrees. So the sine of 90 degrees, well, that's easy. That's sitting right there. Remember, it's cosine comma sine, so that answer is 1. Cotangent. Well, if we got the tangent by putting sine over cosine, we'll get cotangent by putting cosine over sine. That's 0 over 1. That's equal to 0. And to find cosecant, well, that's the reciprocal of the sine function. So if I look at the 1, I can say cosecant is a reciprocal of 1, which is a 1. Now, the only thing that's a least bit tricky over here is that we do have things that come up undefined here. That's because when you put the 0 on the bottom of the fraction, the answer is undefined. So if you're starting with an undefined number, it means that 0 was on the bottom of your fraction. And so that means the 1 or the minus 1 would have been on the top of the fraction.